Good afternoon, good evening, ladies and gentlemen. Welcome to another series of tutorials with me, Aubrey. In this lesson, we continue with implicit differentiation. Now, we did a few examples in our physical classes. Now, this is just an extension of that. So, let's look at question number two here. The question reads, when u is eliminated from the two equations, these are the two equations, all right, we get an equation that is of the form that only has x, y, and v. Okay, when u is eliminated from these two equations, we get an equation that only has x, y, and v in it, which defines v implicitly as a function of x and y. All right, say h of x comma y. So here, what they've said simply is that v is equals to h of x comma y. So now this is very important. We need to put this into or on the back of our minds because it will be very helpful. Very helpful. So defines v implicitly as a function of that. So yeah, so that is v is equals to h of x comma y. So now let's find this function here, the function that we get when we eliminate u from these two. So eliminating u from these two is just making u subject either in here or in there and replacing in another equation. So I'll choose making u subject here and replacing there. So we are going to have u is equal to x minus v. That is when you make u subject in here. And now we replace there. We have y is equals to where there is u, we put x minus v. Then we have a v squared. Hope you can see that. We have a v squared here. So multiplied by v squared, we're going to have y being equal to x v squared minus v cubed. Taking everything on one side of the equation, we're going to have y minus x v squared plus v cubed is equals to 0. And now this is the function that we're looking for here. As you can see, it only has x, y, and v. All right, so simply we can say f is equals to that. Now, after doing that, we come to the questions now. The question says prove that the x is equals to that. Prove that the dx is equal to that. So remember the h is the same thing as v, as we said here. So this is the same thing as saying, let me just write it here, saying the dx is the same thing as the v dx because h is equals to v like that. So now remember, let me write my equation here. F is equal to y minus x v squared plus v cubed. All right, so that is our equation. Now remember the formula for implicit differentiation. This is equals to negative the f, the function that you have here, f, which is an arbitrary function, over whatever is at the bottom there, which is the x, then divide by, again, the f over whatever is at the top right here, which is the v, so dv. All right, so now it's just a matter of calculating now what is f with respect to x. F with respect to x, that will be negative v squared. All right, and what is f with respect to v? F with respect to v, we're going to have actually we should have started with, okay, let me write this starting with the highest power, that is v minus x v squared plus y. Okay, I've written this starting with the highest power. I've just rearranged. So f with respect to v, f with respect to v, that will be 3v squared minus 2xv, like that. All right, so from here, what we can do is we can simplify. As you can see, we have a v here and a v there, so we can factor that out. So that will give us, actually on top, we're going to have v squared. Then at the bottom, we factor out the v. We're going to remain with 3v minus 2x, like that. Then, as you can see, we can cancel out the v there and one of the v on top there, leaving our equation to be v all over 3v minus 2x. But remember what we said. We said that v is equals to h of x comma y. So where there is v, we can replace that. So we say this is actually equal to h of x comma y all over 3 h of x comma y minus 2x, like that. And we are done. So that is what you were supposed to do to show that the h dx is equals to that. So now the task I am giving you is to do the second one. All right, so I have done the first one. It's just the same procedure. So I have done the first one. So now find uh, the h dy. So you can send me on my WhatsApp, my WhatsApp line. You can send me the solution. So you're going to do for the h dy. Okay. For those that don't know my WhatsApp solution, I think that is plus two six. I mean my WhatsApp line plus 20979037378. This is my WhatsApp line, so you can communicate on anything that you want to find out about the question. All right, so have a great day. See you.